let's go over the solutions. I'm going to bring a piece of paper here. We're going to build a decimal to binary converter using only 4 bits. So let's analyze our problem first. So with 4 bits, if I do 2 to the power of 4, I get 16. So I can represent numbers from 0 to 15. And what else it's needed here? We're going to use the division method. So let's go over here and recap the division method. So if I can go and have numbers from 0 to 15, let's say that I have the number 10, and let's say that I have the number 10, and I'm going to divide 10 by 2, gives me 5, remainder 0. So this is where I have my remainder. Then I'm going to divide 5 by 2, which gives me 2.5, or a 2 with a remainder of 1. Then I divide it by 2, which gives me a 1, remainder 0. And then a 1 divided by 2, 0.5, 0, or remainder of 1. And now I read my numbers this direction to get my binary number, and I get 1, 0, 1, 0. Let's confirm. Let's see if this is 10. Let's do the opposite now. Let's convert. Actually, let's stick to the convention. Space 2. And then now let's convert this number to decimal. So if I use 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0, or 1, 2, 4, and 8, what I have is 8 plus 2 equals to 10. And this is correct. Alright, cool. So now we just need to do in LabView this operation, the 4-bit decimal to binary converter. Let's start by creating the project. Open LabView. Create project. We're going to create a blank VI. Finish. And you get a front panel and a block diagram. I'm going to organize everything under this folder, ENGR 1632 labs, week number 2. I'm going to keep all my VIs for this lab under this folder. Let me create something here. So I need an input, a way to tell which number do I want to convert, which is my decimal number. And I'm going from 0 to 15. Let's make this guy a little bit bigger. Alright, decimal number. And I'm going to have the output, which is binary numbers. The best way to probably represent binary numbers is with Boolean numbers or LEDs. So I'm going to have some LEDs here, and I will need 4 of those. 1, 2, 3, and 4. As I add them on my front panel, they start showing up on my block diagram. And next, if I press play, it only runs once, so I'm going to right click, create a loop, a while loop, include everything inside of the while loop. My stop condition, my loop condition to stop, I'm going to right click and create a control. This creates a stop button. Then I'm going to make it slightly bigger too and put it below my LEDs. And I'm going to save my project. under ENGR Labs week 2, and I'm going to call it decimal to binary using the division method. It's going to be my division VI. If I go to folder, everything is organized properly, and I'm ready to keep developing the solution. Let's give meaningful names to these LEDs. So these are going to represent the zeros and ones to our answer. I'm going to call these bit 0, the least significant bit. This one will be bit 1, this one bit 2, and this one bit 3. For my decimal number, I want to send only natural numbers from 0 to 15. So if I run this, notice that I can get those decimal values over there. I don't want that. So let's stop. How do I fix that? Right click on your number, go to representation. Right now it's a double precision, so you can represent real numbers. I want anything around these values over here, integers, natural numbers, and I want probably the U unsigned, no signal, plus or minus, or sign, sorry. So I'm going to pick the unsigned 8 bits. If I press play, now it's all natural numbers from 0 to 15. Notice that it changed the color in your block diagram. It's no longer orange and it becomes blue. This is my decimal number and these are my bits. And now the first operation that I have, if I revisit what I did here, the first operation is my input number, the number that's coming from the knob, divided by 2. Let's see which operations do I have available. If I go to numeric, I have addition, subtraction, division, and I have this quotient with remainder. So I'm going to press that one, put it here, and the remainder, if I go here, the remainder is going to be the least significant bit of your number, because remember I read the numbers from bottom to top. So that means that the result is going to be my bit 0. It's going to be there. Now let's plug the numbers. If I don't know how a module works, I can press the question mark. It opens the context help block, and if I hover, a block will tell me how it works. So here it does the division x by y, and I get the remainder and the quotient over there. Alright, cool. Let's connect things together. I'm going to create a constant, and I know that the division that is done is by 2. I know on the other end I connect my decimal number and my output. I cannot connect my output directly to the boolean. Let's see what happens if I do that. If I do that, notice that it gives you an error. So if I press the broken arrow, it tells you like you cannot connect to terminals of different types. So I need to convert this remainder to 0 or 1. So I'm going to delete the wire. Control B cleans all the broken wires. And before we do that conversion from orange to green, let's see if we can understand a little bit more how this module works. I'm going to do a right click and create an indicator for this one, and right click, create an indicator for that one. Going to my front panel, and I see that I have the indicators over here, so I'll be able to see the answers, the outputs of that module. And let's press play, and let's put our 10, it's our number. And if I do 10, so I'm doing exactly this division over here. 10 divided by 2 gives me 5 and a remainder of 0. That's what we have here. 10 divided by 2 gives me 5, sorry. So your 10 divided by these 2 gives me 5, so 5 is coming out of there, and the remainder is 0. And then the second operation is going to be 5 divided by 2, so let's put a 5 and see what you get. So if I put 5 divided by 2, I get a 2.5, or the nearest integer, which is 2. and then a remainder of 1. It's telling me that I have a remainder. And notice how it computes the remainder. It's actually pretty cool. It's telling you that what you do is x in this case is 5 minus your y, which is your 2. Sorry, let me just erase here. Your 2. And it multiplies these by the result of your 5 divided by 2, which is 2, which is going to give you 1 because you have a remainder. So this is the way that it's computed. So if I go to, for example, the next one, so 5, so if I go to 2, I get 0 as a remainder, and if I go to 1, I get 1. So all I need to do is to look at the remainder, compare with 1. If it's equal to 1, I light the LED. If it's equal to 0, I turn off the LED. So let's do it. I'll stop. I don't need these anymore, so I can erase them. Control B to take care of all the broken wires. Disappears from here. And I right click, comparisons, and I find my equal module. Put it here. The output of the equal is green, so Boolean connects there. Remainder connects to that one. Right click on the other parameter, create the constant, then I'm going to compare with 1. If it's equal to 1, I light the LED. And the quotient is going to connect to our second division module. So right click. Let's go numeric quotient, and you connect this one over there, and over here you create your constant number 2, and we're doing the second part of the division, and we repeat exactly the same thing. Alright, let's test our conversion. Press play, and if I have a 0, get a 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it's done. Your decimal to binary converter using the division method with 4 bits. The second part of the lab is to develop the opposite, a binary to decimal converter using the same amount of bits, so 4 bits. Let's bring our panels again here. And where do I have that information available? I have that information available from the remainder. So I have 1 bit here, 1 bit here, another bit here, and another bit here. This is giving information from bit 0, so this is going to be your least significant bit. Bit 3 is going to be your most significant bit. So let's go back here to our notepad, and all I'm doing is I need to apply or do this operation over here. What I have over here, what I just did on this second part, that's all I need to do. So I need to compute the multiplications between the respective decimal weight and the binary number, and I'll do that bit by bit. So notice that the least significant bit is going to multiply with 1, and the most significant bit is going to multiply with 8. So okay, so let's implement that. I go here, I know this is the least significant bit. I'm going to my numerics, multiplication, and I get I need to multiply my binary number, which is this guy, my bit, with create constant, and the weight is 1, 2 to the power of 0. Get another multiplication, and now I'm going to multiply with my second bit. This one is going to be 2 to the power of 1, which is 2. Let's see if I can have, okay. Then my third goes to my third bit, right click, create, 2 to the power of 2 is 4, and at last my most significant bit, my last one, create constant, and it's my 2 to the power of 3, which is 8. And now, so I just did the multiplications, and now I need to do the summation, sum everything so I can get my answer. So let's right click, different ways of achieving that. You can put a bunch of add modules in front of each other, or I can do a compound arithmetic. If I place this one and I expand it down to the number of inputs that I want, I have 4. Here the arithmetic that I'm going to use is the add, and I connect the multiplications to the respective input, and then my output, I'm going to create an indicator. This is going to be your result. Going to write, yeah, result is fine. And if I press play, the number that shows on the result is going to be the number that you have on your dial. So 4, 5, 6, 7, 8, 9, 10, all those numbers. So notice that I'm doing decimal to binary, and then binary back to decimal.